So let me go to 1.5, the question for that.
Okay, cool.
Okay, so which question do you have problem with for 1.5?
25 and 28.
25 to 28? Okay.
Yeah.
25. This is this one here.
Yeah. I know someone posted on Blackboard, but I don't think they either like didn't get a reply or like I was still pretty confused.
Oh, okay. I see. Okay. So I think your question should have something very similar to my question, except they just change the numbers here. Okay. So basically, they give you the exponential function, two different values, P naught A4 and then A3. So the difference here is just 4 and 3. 4 is the time when t equals 4, and 3 is another time when t equals 3. And you still have two different values. And were you able to find A and P naught here?
Yeah, that was what I was kind of confused about.
Okay, so basically, if for any exponential function, if they give you two data, two values for two different times, then you can just take the ratio between those two values here. So I can, let me see, I can write P naught A4 equal 9, and then just take the ratio dividing by the other one, P naught A3 equal 10. Now, if you take the ratio, then you just cancel the P naught together, right? So now A4 divided by A3, subtract the exponent, so 4 minus 3, so you get A.
Yep.
And equal 9 over 10, or 0.9, right? So that is how you got 0.9 for A.
Gotcha.
Right. And once you get A, and we know that we have the formula P equal P naught AT. So now you can write P equal P naught, and A now is 0.9 T. Right. So the next step is to find P naught, and again you can use any of the two data value here to find P naught. So let's just use this one here. P naught A to the third power, and A now is 0.9. So 0.9 to the third power equal 10. Then now you can solve for P naught. Right? So 0.9 to the third power is equal to something, and then take 10 divided by that on both sides. So 0.9 to the third power is 0. P naught times 0.729 equal 10. And now you can solve for P naught by dividing by this value here by 10 on both sides.
Okay.
And that should give the initial value here.
Awesome.
Right. And the next for part B, they ask you to state the initial quantity. We already know that that should be the P naught, the initial value. So the P naught just go directly to here.
Okay, cool.
And in order for you to decide which one is decaying or roving, then you have to find the value for the rove or decay rate. We know that A is 1 plus the rate, right? So A now is 0.9. 0.91 plus the rate. So you solve for R. That is 0.9 subtract 1, or that should be minus 0.110. And minus implies for decay. Right? And 0.10, if you convert this back to the percent, so move it to the right 2 decimal places equal to 10%.
Gotcha.
Right? 10%. You can click on, yeah, that should be 10%.
Okay, cool. That makes way more sense now.
Yeah.
see what the next question I had was 1.6. Number
1.6 now. Okay,
Yeah.
let me. How do I move to 1.6? I think I have to clear all the job. No, it's not. Okay, let's go to 1.6. So we go back to here. Let's go back to Blackboard. One point six.
Mhm.
Okay, it's here. Okay, so what's question for 1.6?
33.
33
Mhm.
here.
So I guess it's like a similar problem though.
Yeah. Let me try to solve the solution so we can explain it from there. 33. Okay, that's good here. All right, that's me explaining. So you are still able to see all the screen, right?
Mhm.
Okay. So now we are given again exponential function p equal p naught e to the kt. In this case, we are given the base e and k is the continuous growth rate. They give you the value for the time t equal 4, p equal 30, and the time t equal 3, then your p should be 60. And they ask the same type question they ask you for k and p naught. The last case you found a and p naught. Now it's k and p naught. So the same thing, we just using you take the ratio, right? Because now you plug in t equal 4 for t, you get pk 4k, and p naught, and the value is p is 30 is here, right? And the same thing for 60. Your p is equal to 60, so 60 is here, and p naught e to the t, now the time t for 60 is 3. That's why you have 3k's here. And now you can take the ratio between the two equations, and that will cancel the p naught again. And 30 divided by 60, that is 1/2 or 0.5. And e to the 4k divided by e to the 3k, 4k subtract 3k, that is 1k. And once you get the 1k, then you can solve for k by taking the ln on both sides. So I take the ln and then the ln. The ln of e, they cancel, so you have k on the left side. So ln of 0.5 is your k. So which is minus 0.693 is here. Right. Yeah. And once you know the value for k, then you can plug in k to either one of the two equations here. So I picked the first one. So p naught e to the k 4k equal 30. And now your k is minus 0.693. And you can find p naught by dividing by 30 by the whole thing on the left side here to isolate for p naught. And that should give you 479.717.
Gotcha.
Right. Does that make sense to you?
Yeah.
Okay. And again, the initial, let me clear the drawing. Okay. And then the initial value should be the p naught. Again, the same p naught.
Okay. So for that real quick, that last part, the p naught e to like the 4 and then like multiply or like and then times negative 0.693. So That equals
30.
30? Okay.
Yes.
Okay. And then you just do e to the 4.
Yeah, you just plug in. You just use a calculator to find e to the power 4 times this one, and whatever you get here, you just take 30 divided by both sides, so you can solve for P naught.
Okay. That makes sense.
And we know that the initial quantity is just P naught.
Mm-hmm.
And in this case, K is the negative value. So again, it's decaying.
Yeah.
And again, you can find the percent by moving 2 decimal places to the right. So 69.3% per unit time.
Awesome. Okay, that actually makes way more sense now.
Good. Okay, what's the next question that you have?
1.6, number 40. I feel like I knew how to do this question, but like for some reason, like what's it called? Wiley Plus wasn't like said my answers are wrong.
Okay.
Like I'm plugging into plugging in like one into like for the T, and then like the first part putting like 0.5 into the T, but I don't know why like they were incorrect, I guess.
Okay, let me see here why is that okay. So you was able to find let me open the
so I got the last one.
Okay.
But I didn't get.
So P of T equal this equation, this function here. So P of 6 months, you're just gonna plug in 6 for T.
Right.
And then the value should be this one.
Okay, let me plug that in real quick to make sure I got it. So I plugged that in.
Oh, no. They said that T here is in years. So 6 months is just 0.5 year.
Yeah, that's what I did.
Uh-huh.
And then I put like for P and then of 1 year I put in 1 and it said I was wrong. So let me make sure I got that.
Okay, then let me find a calculator so I can try that with you here. So if the you said that P of 1 year is not correct.
Well, let me see what I put for that because I know.
Okay, let me try it now. So minus 0.5 power and multiply by 1500. I got the correct value. So I got if I plug in 1 for T and then in my calculator, then I should get the number here.
Okay, yeah, now I'm getting the right answer. I'm not really quite sure why, but
909.79. So they route it to 910.
Okay, maybe I was rounding it incorrectly.
Routing, yeah. They route to the whole number, so 910.
Okay, cool. I got them now.
Yes.
Okay, and then my last few questions were on 1.7.
1.7.
Yeah.
Section 1.7.
Yeah. Those are I had like 2 questions on that one, or 3 questions on that one.
Okay, let me go back to Blackboard 1.7. Yeah. .7. Okay, here. Okay, what's question for 1.7?
The first one is at 19.
19 1.7. Okay.
So I got the equation, which or for me, wait, 1.718. Okay, so for me the numbers on mine are different than the one on yours. Mine says for 1.7 it says a cup of coffee contains 100 milligrams of caffeine, which leaves the body at continuous rate of 31% per hour. So it says for you.
Oh well, let's just work with my number, and then you can try on your once you understand the question.
Oh, okay.
Okay. So basically, that it's saying that the decaying rate is 24%. So it should be minus 0.24 if you convert that back to the decimal.
Yeah, I got the equation right.
The equation.
Yeah, I got the equation right. I just need some help on like the half-life one.
Or the half-life. Okay.
Like
So they ask you use the graph below here, and to estimate the half-life of the caffeine to the nearest hour.
Mm-hmm.
So the half-life is it's the time that it takes for the initial amount of 100 milligram to decay to 50. So if I use, so 100 is here, so 50 is here. So let me open the chopping. Okay. So 50 is here. So you go all the way to the right until I hit the curve. Then from now you can just go down to the timing. It should be 3.
Gotcha.
All right. 3.
Okay. So for mine it's like 2.2 or 2.3.
Yeah, so yours should be something, just estimate it from here.
Okay. Gotcha. Okay, and then I think for that one. Okay, and then this for C it says use logarithms to find the half-life of caffeine to 2 decimals. So how would I do that?
Okay, let me go back to this one. Clear the chopping. Okay, use the log to find the half-life to do some 2 decimal places. So okay, let's go back to here. So let's take a look at this one. So the initial value was 100. So the half-life is when the amount of that is 50%, or it's 50 milligram. So you go back to the equation that you have here from part A. Now, the final value A, you want to set this to 50.
Right.
And then you just solve for T. Right.
Okay.
So 50 now is for A. 50 equal this one. So divide by 100 on both sides. You got 0.5 equal e to the something here. And then to solve for the exponent of the base E, you take the ln on both sides.
Okay.
So ln of this one, when you take the ln, you just got the exponent. And then dividing both sides by minus 0.24, you get T to be 2.889.
Gotcha. Okay, that makes sense.
Yeah.
Okay, cool. That makes a lot more sense.
Yeah.
Okay, got that one. And then the next one is 1.7, number 29.
29. Okay, here.
So this is another half-life one, I guess.
29. Okay, let me open here. So they said that if the quantity of a substance decreases by 6% in 11 hours, find the half-life. Okay, so you know that the equation for the exponential function is some quantity t equal the initial value and time e to the kt. Okay, and we know that it decreases by 6 hours in 11 hour. So 6%, that means after 11 hours you only have 94% left of the substance. So the Q of T, when T is 11 for here, when T is 11 for T, then you only have 94% of the initial amount, or 0.94 Q naught, when T is 11.
Okay.
And now Q naught they are on both sides, you can cancel Q0 or dividing by Q0 on both sides. You end up with 0.94 equal e to the k times 11. And then solve for k by taking the ln on both sides and then dividing by 11 to solve for k.
Okay.
So k should be this number here.
Got it.
Okay.
So I'm kind of confused on how it like the q equals q naught e to the kt. How it came from like q to q naught. I guess I'm confused about.
Q of t is just the quantity at any given time, and q naught is always the initial value.
Mm-hmm.
So
go ahead.
So this basically q is just p and q naught is p naught.
Oh, they equal each other?
Yeah, they are just using a different letter.
Okay.
Right.
And then so it says.
And then once you get the k or the continuous array, let me go back to the created the drawing before. Okay, then you once you have k, then you can go back to the equation here. Then your k should be minus 0.056, and now you are trying to solve for the half-life or the timing t. When the half-life occurs when the initial value decreases to 50% or half of that. So now your final value is 0.5 of the initial value or Q naught when your K is you just found here from the last step. And the only missing value here is just the timing T. And the Q naught, they are on both sides. So you can divide them to cancel that. And again, taking the ln on both sides, you end up with this line here, the third line, and then dividing by minus 0.0056, you can solve for t. So the whole point is that we need to figure out the value for k first from the given information here, and for the k, we then can plug in k to the equation, and we set the final value to be 50% of the initial value, and then solve for the timing t, because that is the time when the initial amount of anything is reduced by 50%.
Okay. So once you find t, then that's like
the half-life. Yeah.
Okay.
So after this amount of time, 124 hours, your anything here will be decreased by 50%.
Gotcha.
Yeah.
Okay.
The next, any other question for this section?
Yeah. The last question I have is 1.7 question 50.
50. Okay. Okay. 50 is here. All right. So are you able to do part A or which part do you have problem with?
It's loading. I forgot 1 second. 1 second. It's still loading. Yes. Oh, okay. So I don't really exactly know like where to start, I guess.
Okay. So let's try this question here. It says a company is considering whether to buy a new machine. It's cost for $97,000. Now the cash flows would be generated by the new machine given in the following table. So after 1 year, it's 50K. 2 years, 40K. 3 years and 4 years and so on. Now, finding the total present value of the cash flows, and take each year cash flow at a sum lump at the end of the year and use an interest rate of 12.5% per year, compounded annually. So if you are talking about a compounded annually, then let me pull out this here. Okay, so go back to the formula that we had in the class. So let me write that here.
The P naught times A raised to the T.
Yes. So it's P naught, P equal P naught 1 plus R T. Right. So this is the one for compounded annually. Now we are finding the present value. So if you go back to the formula on page 61, then the present value when compounded annually is P equal B divided by 1 plus RT. You can just ignore this one because now we're using the present and future value. So that's just, just write that. Let me write it again. P equal B divided by 1 plus RT. So this one is the present value when compounded annually on page 61, the formula.
Okay.
So we can find they asked you to find a total present value. So now we're using this one here. So the first one, the payment is $50,000 in year 1, and the rate. Let's go back to the rate. The rate here is 12.5 or 0.125 in decimal. Right. So R here, R is 0.125, and 1 plus R is 1 plus 0.125 or 1.125 for the bottom. So the present value P of the first year or year 1 is equal to the future value, and the future value is just 50K here at the year of T1. So we don't have any power here because T is 1. So that's why you got 44,444 here. Do you get to this point now?
Yeah. So it's just
yes.
So B would be like the future rate, so that'd be 50,000.
Yes. And the next one is 40,000, and 40,000 go to B, and that is the year 2 or when your T is 2.
And then you just raise the and then it's just raised to the year, right?
Yeah, and then you add all of them together, you get the total 106. Yeah.
Okay, that makes sense.
And it asks you based on a comparison of the cost of the machine and the present value of the cash flows, would you recommend purchasing the machine? And yes, because the present value is larger than the price of the machine. The price of the machine is 97K, and you got the present value is 106,000.
Right.
So yes.
Okay, got it.
Awesome. Yeah, that should be all the questions. Yeah, in this question.
That's perfect. Thank you so much. I really appreciate it.
All right, no problem.
I'll see you in class tomorrow. Have a good evening.
You too. Bye-bye.
Thank you. Bye.